So the other day, Sleeping Warrior was on Randy Flat Earth channel, and he was trying to debunk what Rumpus had said about atmospheric refraction. And of course, it was your typical Anthony Riley presentation of complete ignorance. Now, at the end of the month, Rumpus was a guest on Ranty's show. And of course, he was talking about atmospheric refraction and how looming can bring objects from behind the horizon on the globe. And one of the examples he used, you can see it right here. This is a sugar solution with a density gradient. And you can see that light is bent downward in a curve. There's many examples of this on the internet, and we'll just take a quick look at one right now. So you can see that the light clearly bends in this density gradient. Of course, Anthony is having none of this. He doesn't believe that light can be bent in a curve by a pressure gradient. So he used this video to make another claim. So let's take a listen to Anthony's explanation.
What this guy does is he's got the three different types of sugars. There's glucose, fructose, and whatever the third one is. And you're not going to hear the sounds, but it doesn't matter. What he's got is a polarized light filter behind it that represents atmospheric light. And what he shows when the video, when he moves the light behind it, you can see the effect of the light. Yeah, he talks about the rotations here. He's got the three sugar molecules. We've got sucrose, fructose, and whatever the other one is. And he talks about the rotation of all three of them. Now you'll notice that two of them are positive, 66, 52, and one of them is negative, so 92. So as he moves the light behind it, the filter, or passes the light behind it, two of them are going to go to the right or the left, and then the other one's going to go the opposite way to a lesser extent. Now what this is proving is that it's the dextrorotation of the element of the sugars that is bending the light. It's not the density of the gradient as Rumpus claims.
Sorry, Anthony, but that is a claim of complete ignorance. The first thing you needed to do was understand what is polarized light. A quick Google search would bring up many examples. So here we have an explanation of linear polarization. So down here on the left, we have non-polarized light wave, and that is a light wave that oscillates in more than one plane. So here we have a polarizing filter, and when the light passes through that filter, now it is oscillating in one plane. So here is a Google search of what is dextrorotation of polarized light. And again, there are many examples. So a dextral rotary compound is a compound that rotates the plane of polarized light clockwise as it approaches the observer. It would be similar to if you turned your steering wheel on a car to the right. And here is an example. We have a light source that is unpolarized light. It goes through a polarizing filter, and now it is oscillating in one plane. Here it goes through a sample tube containing a chiral compound, which would be your sugars. And what do? They twist that plane to the right. There is also level rotary compounds, and these rotate the plane of polarized light counterclockwise or to the left. And this is exactly what this guy explains in his video. Let's take a look.
This is a solution of sucrose. It's a chiral molecule, and it's dextrorotatory, i.e. it rotates plane polarized light to the right, so it's now able to pass through the second filter.
So what he says matches the definition of dextral rotary compound. Now you also notice that he mentioned a second filter. So let's take a listen to his setup.
This is a polarizing filter I borrowed from the physics department. There's a second polarizing filter mounted to the front of the lens.
So we added a second filter after the sugar sample. And if you twist that filter to the left, it will be in -degrees. Twist it to the right, and it will be in +degrees. So if you align this filter in the same plane as the light coming through the sugar sample, then you will see a lot of light. If this filter is not aligned with that plane, then you won't see much light at all. So down here is a screenshot from his video, and we can see on the left not much light is coming through, but on the right a lot of light is coming through. And that is because the Dextrorotation matches the analyzing filter. Now in this case we see the opposite. On the right we don't see much light coming through, but now on the left we see a lot of light coming through because again the analyzing filter matches the plane of light coming through that sugar sample. So sorry Anthony, everything you said about dextro and level rotation is complete nonsense. It has absolutely nothing to do with the bending of light or refraction. So now Anthony is going to move to some more cherry picking as he talks about refraction. Let's take a listen.
These three papers are what I rely on, and I've done this for ages because what they do is they demonstrate actual science for what light does. And these papers don't exist anymore on the internet because, or they may exist somewhere, but what's his face? M. Scott Veach had them removed because he doesn't like me using them.
Well, Anthony is right because these papers are still available. The problem is, though, is that you need to be able to log into the site. It's just not open for the general public. So let's continue with Anthony's explanation of refraction.
And he talks about the application of Snell's Law, but this is the key part I want to focus on. Under normal or standard circumstances, that would be Rumpus's version of 7.6R. The effects are again negligible. Well, if I pull up a definition for the word negligible, you can try it yourself. It just says so small or ineffective it isn't worth considering. Yet his whole argument is based on refraction.
So yes, standard refraction, the effects are negligible. But what do we see in the next sentence? It is under non-standard circumstances when we really see some amazing atmospheric phenomena. And it immediately starts talking about inferior and superior mirages, and this would also include looming. So let's hear some more of Anthony's cherry picking.
This article here, it was written by school kids, high school kids from Singapore or Hong Kong or wherever it was, secondary school kids, and they get it. Rumpus is telling people incomplete information that's just not true. And he's misleading people into thinking that light follows a curved path. It doesn't. In this article, it says it's well known that the Earth's atmosphere is not homogeneous or homogeneous. As a result, light traveling in the atmosphere will undergo refraction, and this is the key bit, and the traveling path will deviate from a straight line, right? Now, there's a moot point there, a semantic point to what does that mean? Does a traveling path deviating from straight, is it a wave? Or is it actually a curve?
Well, here is that article, and Anthony is right. These kids do get it because they do give examples of light bending in a curve. So let's take a look. So you can see here's two examples, inferior, superior mirage, and we see light bending in a curve. And again, 9.1, typical inferior image. And again, we see light bending in a curve. And this is from page 24. It's circled in red right here. To find a path between two given points, the program is configured to test a range of starting incident angle. For each angle, a unique curve of path of light is obtained. Anthony, this article does not support your claim. Now, this is what I think Anthony's problem is. He understands Snell's law. So up above, we have a less dense material, down below are more dense. So as light enters that point right there, light is bent at the barrier between the two. And of course the opposite is true. When light comes back out, it is bent in the same angle. What Anthony doesn't seem to be able to comprehend is what happens when we have a density gradient. Well, what happens then? You get a lot of little bends as light travels through. And what does that produce? It produces a curved ray of light. And here's one other thing to consider. So here we have an example of a flat Earth with an atmosphere that has a gradient. So if a light ray is traveling parallel to the Earth's surface, it's going to be basically staying in the same density. Now, of course, there can be variations within here, but it's not going to bend like it would on a globe. Because on a globe, what you would do is you have a light ray over here on the right that is starting off parallel to the Earth's surface. But as it travels, it starts moving upward into the less dense air. So then it is going to want to bend down. So a globe Earth is much more conducive to light refracting downward.
So ultimately, it comes down to if light's deviating from straight, it is not following a curve. The rumpus can't prove his claims. He's deceiving people with telling people false statements of fact, and he satisfies the definition of a psyop. He's conveying selected information to influence their beliefs and opinions and motives or whatever. And rumpus is the epitome of a psyop. All I'm doing is pointing out that he's not telling you the truth.
Well, memo to Anthony, you might want to think again about who is telling the truth, because to be blunt, your presentation was 100% bullshit.